And you will have a few questions on your test next Tuesday, about 2 questions on your test about weighted averages. So first of all, we need to define what a weighted average is. A weighted average is found by multiplying each data value by its weight and then finding the mean of the new data set. And so when we find weighted averages, we generally call those problems mixture problems, and that's where 2 or more parts are combined into a whole. And so if you look up here on the board, here's my first problem I have. Tasha ordered soup and salad for lunch. If Tasha ordered 10 ounces of soup for lunch and the total cost was $3.30, how many ounces of salad did Tasha order? And you're probably wondering, why would you ever pay per ounce? Actually, there are some places that you do pay. Based on this, like the salad you make, they go and weigh it and they charge you based on how many ounces you've used. So it is a realistic problem. Okay, but we know we've got soup and we've got salad, and I know if I add those together, I get my total, right? So I'm just taking the soup plus the salad, and that'll give me the total. And if I look, I know that Tasha ordered 10 ounces of soup. So I ordered 10 ounces of soup here. And how much does the soup cost? No, how much does the soup cost? 15 cents per ounce. So what I'm going to do is I'm going to take 0.15 times my 10. Now why did I do 0.15? Because it's, well, not percent, it's money. Because it's money. So now what's the salad cost? 20 cents. Do I know how much salad that Tasha bought? No, so we'll call it what? We'll call it X. I would use an S. The problem with an S is sometimes it looks like a 5. Okay, so that's one of those things we usually like to stay away from S's. And so then how much was the total bill? $3.30. Okay, so now all I need to do is solve that. So what is 0.15 times 10? And remember, you can use your calculators. It's 1.5. Good job. Plus 0.2x equals 3.3. So how do you solve that for x? Subtract 1.5 from both sides. So on the left side, I have 0.2x. On the right side, what do I have? What is 3.3 minus 1.5? 1.8. Now what do I do? Divide both sides by 0.2. So what do you get 1.8 divided by 0.2 to be? Close. I just get 9. Okay? So the answer, how many ounces of salad did Tasha order? 9 ounces. So that's one type of mixture problem you're going to have. Okay? There are other types of mixture problems, and that's what we're going to look at now. Okay? This says one type of antifreeze is 40% glycol, and another type of antifreeze is 60% glycol. How much of each kind should be used to make 100 gallons of antifreeze? That is 48% glycol. So we have 2 amounts, and we're going to mix them together to get the third amount. How much is the first amount? 40%. So I've got my 40%, and I'm going to add that to what percent? 60%, and my net result I want is 48%. So the first thing I'm going to want you to do is go ahead and do the percents and figure those out. The next thing we're going to do is attach amounts to each of the percents. Now, is there any amount that I know that goes with a particular percent? So do I know that like I have 5 gallons in one of these? Or like 10 gallons with one of the percents? What does it say in the problem?
You can do this to make it
100 gallons. Right, that's an amount. So where does the 100 go with? What does it say? What percent does it go with? It goes with the 48%. Very good. So I know that I've got 100 gallons with the 48. Now, do I know any other amounts? No. So I'm going to show you how we go ahead and find what goes with the 40, what goes with the 60. Okay, the first one I'm going to let be X. So if I know the final amount, like I know this is 100, I'm going to make that first one X. Now the second one, what I'm going to do, and this is going to look really weird, I'm going to take the final amount, the 100, and I'm going to subtract the X. And you will always do that. So if the last one was 50, I'm going to put 50 minus X. If the last amount was 75, I'm going to put 75 minus X. So this is always what you're going to do. The first one will be X. The next one will be your final amount minus X. So now what I need to do is go ahead and write an equation. How can I write 40% as a decimal? 0.4x. Okay, how can I write 60% as a decimal? 0.6. And notice I've got a quantity, so I'm going to put parentheses. Somebody tell me what the right side of the equation is going to look like since I did the left for you. 0.48. And then what? Not over. Times. Yeah. Times 100. So all I'm going to do is multiply those two rows. So now I just need to solve this. So first thing I'm going to do is I'm going to leave my 0.4x alone right now. And then let's go ahead and distribute those two. So what is 0.6 times 100? 60. Yep. Minus, what do you get? 0.6x. Very good. Equals 48. Yep. Now on the left side, what do you notice? You should have two terms that are like. Okay, 0.4 and then negative 0.6. What is 0.4 minus 0.6? Negative 0.2. So I've got negative 0.2x plus 60 equals 48. How do you solve it now? Subtract 60. Good job. And so I get negative 0.2x equals yep. You were going to say it first. Oh, I thought you were going to say something else. Negative what? 12. What do you do now? By negative 0.2. Good. So what does x equal? Six? I think it should be 60. Okay. So your first one is 60 gallons. Then I need to think, what plus 60 gives me 100? Or what's my next amount going to be? 40. 60 gallons and 40 gallons. That's what you're going to need. Because 60 plus what will give me 100? Okay, yeah. So see, both of them need to add together to give me 100 for my final amount.
So for a problem like that, we have to put either equal or 60.
Well,
One of those numbers.
right. And this is just a fluke that 40% and 60 matched up and that 60% and 40 matched up. It usually won't match. It won't usually match like that. Okay, let's look at another one. Margot has 40 milliliters of a 25% solution. How many milliliters of 60% solution should she add to obtain the required 30% solution? So what are my percents? 25 plus 60, and that's going to equal 30. So now I need to attach any amounts that I'm given. Do you know any amounts? 40. And where does the 40 go? Under the what? Under the 25. Good. Now this one's different because the amount wasn't here after the equal sign, was it? Okay, so let's go ahead. What am I going to put with the 60%, do you think? What should I put there? Close. Not anything with the 40. Let's just put X, because that's like my first one, right? Because the 40, that takes that one out of the mix. Here's my first one. Now, real quick, do you think I'm going to do 40 minus X for the 30%? Or let's think. I'm going to do something with the 40, and I'm going to do something with the X. Do you think I should subtract them? What's the operation right here? Addition. So what do you think I should do with the 40 and the X? Add them. So this is different. When you don't know the one after the equal sign, you're going to have to add the two. Because remember how the time before it was 60 and 40 gave me 100? Okay, so in this case, my biggest one is going to be the 30%. So let's go ahead and multiply. What should my next line look like? 0.25, and then what? Times 40, good. And then plus 0.6 times X equals 0.3 times 40 plus X. So remember, all we're doing there is we're multiplying the purple and the blue. So what is 0.25 times 40? What do you get here? Good. So I have 10 plus 0.6x equals, what do you do now? Distribute. Okay, so what is 0.3 times 40? 12. Plus what? Close. 0.3x. So now what I need to do is get x's on one side. So I'm going to subtract 0.3x from both sides. So I end up with 10 plus 0.3x equals what? 12. What do you do now? Minus 10. Good. So I get 0.3x to equal what? 2. Very good. What do you do now? Divide by 0.3. So what does x equal? And it might not come out even, does it? What? Okay, so 2 divided by 0.3. Did you do 2 divided by 0.3? Okay, so basically you get like 6.67. So then that's our first amount. That's this amount right here. Okay, so what would be my final amount? How much would I have if I had 6.67 here and 40 here? What would this amount be? So you have 40 milliliters of the 25%, 6.6 of the 60%, 46.67. Yep. Good. And label will be milliliters. Okay. So that's an introduction to mixture problems. Okay, you're just going to have a few of those on your homework. I don't expect you to fully master those because we will again look at those when you're in Algebra 2, a little more in depth. And so finally what we're going to do is we're going to talk about some motion problems. Okay, and these are the ones that you're going to need to focus on for your test. Okay, because you're actually going to have some motion problems on your test. So let's go ahead and look at what slide this says. It says uniform motion problems are also known as rate problems. Distance equals rate times time. Got to file that away and you'll use that in science. Distance equals rate times time. So let's look at this one. It says it took Travis and Tony 40 minutes to skate 5 miles. The return trip took them 30 minutes. What was their average speed for the trip? So when I think about speed, I think about miles per hour, right? I think about something like that. So when I think about that, miles would be something on the top, and time would be something on the bottom. So this is what you need to get down. If you want the average speed will be total distance divided by total time. Total distance divided by total time. So I want you to look at that problem. Travis and Tony, how far did they skate total? What? 10 miles. Because they skated 5 miles there and 5 miles back. It's good you caught that there are 2 sets of 5 miles. Okay, so actually I'm going to even put 10 miles. I'm going to put my label because I think that'll explain things better. Now, what was the total time they took? 70 what? Minutes. So in order to calculate their average speed, I need to take 10 divided by 70. And it's going to be a decimal. Let's round to 2 decimal places. What? 1. 10 divided by 70 should be 0.1. What'd you get? 4? 1428. So what would that round to 2 decimal places? 0.14. Now I need to come up with the label. So that's why I had you write these things in blue, because the label is just going to be miles per what? Minute. Good. So remember that total distance equals total time. With that in mind, let's look at another one that deals with that same thing. Austin. Okay. Austin jogged 2.5 miles in 16 minutes and then walked 1 mile in 10 minutes. What was his average speed? So with that in mind, I want you to go ahead and do this one for me. Okay. So find his average speed. So our total distance, how far did Austin actually jog and walk? 3.5 miles. So that's our total distance. What's the total time? 26 minutes. So when I divide those, what is his average speed? 0.13 miles per minute. Okay, so total distance divided by total time. And if you didn't write that down, you really should. Okay, because the way your book solves it isn't like this. Okay, we're solving it correctly, but it's just they don't have this formula thing written down. Okay, total distance divided by total time. Last thing we're going to talk about is trains. Okay, so we have two trains. They're 550 miles apart heading toward each other. So basically, this is 550 miles. Okay, we have train A here, and it's going this way. We have train B here, and it's going this way. Now, obviously, they're not on the same track. Okay, they're on separate tracks. And so the question is, when will the trains pass each other? Well, that's a good question. So if you remember that formula, we had distance equals rate times time. So when I look at train A, what was train A rate in the problem? 35 miles per hour. So train A is going to be 35. What is train B? 45. Now, do I know how long they travel? Do I know for how many minutes or hours? It doesn't say, right? So I'm just going to write T with each of these. Now, you're probably wondering, why did you put T with there? Because remember, distance equals rate times time. So I've got my rate, which is 35 and 45. Now I've got to attach that time component. So this is what you're going to do. You've got your 35T and your 45T, right? I want to find out, when do they meet each other? So in other words, that means when have they both together collectively traveled 550 miles? So that's going to equal 550. And this problem actually is fairly easy to solve because these are like terms, right? So what is 35 and 45? 80. Very good. So I've got 80T equals 550. How do you solve that for T? Divide by 80. So what do you get T to equal? 6.88. So time will be 6.88 hours. Okay, so real quick, let's go ahead and turn to page 136 and make sure that we have your assignment down. Okay, number 6 is a mixture problem. It's just like the first 2 or 3 that we did. Okay. Number 8, that is just like the soup and the salad one that we did. Numbers 9 and 10, those are like the next 2 that we did. 11 and 12, those are the average speed that we did. And number 13 is the one like the very last one that we did. So you have a total of 7 problems to do. Okay? 7 problems to do for me.
What was the 6th and the 17th?
What?
What was the 6th and the 17th?
6, the 6 is like the first one, some of the first 3 that we did. The 8, 9, and 10 are like the first 3 that we did. The 11 and 12 are the average speed towards the end that we did. And the number 13 is like the very last one that we did.